All right, similar figures. You probably have spoken about congruent figures in year 10 past. Congruent just means that the drawings are exactly the same size and shape. What we're talking about here is similar figures. They're the same shape, but they can be different size. Why is that useful for us? If we know two figures are similar, we can easily resize them using something called a scale factor, which is usually labeled K. What is the scale factor? It sounds fancy, but it's just a division. The scale factor in any situation is just a comparison between the size of two measurements before and after. So the scale factor is most often given the symbol K. For us in Year 11 General Maths, the scale factor is the measurement after divided by the measurement before. Can you get that down, please? That formula there for the scale factor is the measurement after divided by the measurement before. This won't mean anything right now until we do an example. These next two formula as well won't mean anything right now until we do an example, okay? So again, for the people that came in a bit later, this is the second to last teaching of this whole topic, okay? Thursday I'll record, it's called Simpson's Rule, but that's it, you'll be revising for your test then. Remember I pushed the test back after I roasted you all last Friday. You guys missed out on something special. It would have been nasty, and then I asked them to do a pivot survey as well. Probably not the best time to do it. Just get that formula for scale factor. This is not something you need to do for your deal. It's only a test question, and it's literally, it's in the middle somewhere. Okay, how do we apply this, or what are we going to use it for in Year 11? We use it to resize things. We're going to resize area and surface area of similar object. If we know that two objects are similar, we can use scale factor to easily resize the area or surface area between them using this formula. The area or surface area of the new object, whatever it is, if I made it smaller or made it bigger, it doesn't matter, is equal to the scale factor squared, which is K, times by the old surface area. This won't mean anything until we do an example. To find the scale factor, you need to know corresponding measurements on both objects. So what does corresponding mean? If I had a small triangle here and a large one there, if I said this was 1, 2, 3, and this was A, B, C, in the smaller and the bigger triangle, what number and letter corresponds to each other? No? 1 and? A. Yes. So, being in the same place, okay? So if I want to use this formula, I would need to know, in the smaller and the larger one, I need to know how long 1 is and how long A is. Get this one. That's recording, isn't it? Yeah. And last one in this board, we can resize the volume of similar objects using the same formula. What is the only difference between the volume formula and the area formula? Cube. That's the only difference. Okay? If you can save cheat sheet space, you don't have to write both, but that's up to you. Again, to find K, you need corresponding measurements on both objects. Can you get these two formula down, please? Is anyone still on the board one? There's only one thing to write down. We'll do my example. It's quite relevant. Took me 5 minutes to draw that thing. Sorry. Why not? Why can't it be a supreme sticker? Maybe if I was the teacher that put those posters, it would have been, I would like to resize my Taylor Swift quotes to cover the whole oval. Huh? I'm not roasting it, I'm just saying. What if I wanted to resize this thing so it was visible from space? The largest man-made object in the world.
You have to blow that out. So it's like,
Oh, did I?
I did.
How long has it been? It's been about 5 minutes. So. I'll check if it's like audible first because you're sort of talking under your voice. All right, let's see how these formulae work. It's not too bad, and this may or may not be similar situation with different numbers to what you have to do in your test. Mr. T's got a small rectangular supreme sticker. The dimensions are 10 centimeters by 3 centimeters. I want to make a big version to stick on my car that must be 80 centimeters long on the long side. 1. Draw a diagram of the situation. I've slightly drawn the diagram. I've drawn part. Don't worry, I'll protect you if they come over. This is the supreme sticker. What do I know about this supreme sticker? How long is it? 10 centimeters by 3 centimeters. I'm trying to enlarge it and make it bigger. I've told you that to use these formula, I need to know corresponding measurements. What's the only thing I know about the enlarged version? How long does it need to be? He wants to make a big version to stick in his car that must be 80 centimeters long. So all I know is that this needs to be 80 centimeters. That's it. I don't know what the area is. That's what it's asking me to find. Have I drawn a diagram of the situation? I've got a small one. I've got the big one. And all I know is it's 80 centimeters. Okay? That's part A done. Part B, find the area of the enlarged sticker. So I've given you a tool. Area, new, equals k squared times my old area. Does the question tell me what the old area was straight up? Does it give me enough info to work it out? Because it's a rectangle, length times width, 30 square centimeters. So times by 30. But my problem is I still don't know what k squared is. I don't know what k is. But that was on the previous board, I rotated it. What is k? K is the new one, 80, divided by the old one. How long was the old one? 10. So my k, my scale factor is 8. In other words, what is that telling me? The scale factor is I'm increasing this 8-fold. I'm timesing everything by 8. So now, do I know what k is? I just worked it off to the side, 8. But it's squared. Why is it squared? Because we're talking area. So area new equals, what is that? 8 times 8 is 64. You'll have a calculator anyway. So 64 by 30. 1920 square centimeters. Okay? So what it used to be was 30 square centimeters. 30 times by 8 is much smaller than this. But why is it so much bigger? Because I'm timesing the length by 8 and the width by 8. So that's what the squared deals with. Okay? Can you get that example down, please? And then I'm going to shut my mouth for like 45 minutes. I want you to work on the timeline and your DI, 8D to 8E. I've had some year 12s asking me like, oh, what do I focus on? You're in like stage 1 now. You should be able to handle 2 things at once, right? And it's not like these 2 things are completely unrelated. Is the stuff that I'm teaching you part of what your DI is about, right? So the timeline 8D and 8E. A lot of you have already checked your volume and surface area. But yeah, until 12, I need to get back to your 12. Until 12, AD and AE, please.